This tutorial is about a confidence calibrated classifier and related source code. It is well known that deep neural networks do not capture predictive uncertainty. For example, suppose there is DNN trained to classify dog, cat train. If we input some other image that does not belong to a class dog, cat train, the DNN often predicts it as a dog, cat, and train with high confidence. A confidence calibrated classifier is proposed to resolve this issue. In this tutorial, I'll talk about a confidence calibrated classifier for detecting out-of-distribution samples which do not belong to the class that is used in training. There are two components we use to train the confidence calibrated classifier. First of all, we propose confidence loss to classifiers to have low confidence for out-of-distribution samples. Confidence loss minimizes standard cross-entropy loss for in-distribution samples and minimizes KL divergence between the uniform distribution for out-of-distribution samples. As a result, it makes the output of in-distribution samples to 1 and the output of out-of-distribution samples has the same value for all classes. For instance, if we train a classifier on the SVHN dataset to classify digits, SVHN data are in distribution samples, and samples from other datasets such as CIFAR10, TinyImageNet, and ELSON are out-of-distribution samples. If we train a classifier on the SVHN with standard cross-entropy loss, out-of-distribution samples often have high confidence output. However, if we train a classifier with confidence loss, out-of-distribution samples barely have high confidence output. To optimize the confidence loss, we need data from out-of-distribution to minimize KL divergence between the output of out-of-distribution samples and uniform distribution. However, it is not trivial to define out-of-distribution clearly. In fact, out-of-distribution implies all the data except the one used to train the classifier, so it is impossible to use every sample from the entire data space. Our intuition is that samples close to in-distribution could be more effective in improving out-of-distribution detection. We conducted a 2D toy experiment to justify our hypothesis. When out-of-distribution data is sampled from the entire data space, some out-of-distribution data have high confidence. In contrast, when we sample out-of-distribution data close to in-distribution, out-of-distribution data have low confidence compared to the previous one. Since out-of-distribution data close to in-distribution is unavailable, we use GAN to generate out-of-distribution data. In addition to the original GAN objective, we add some KL divergence between the output of generated samples and uniform distribution. This term forces generator to generate low-density samples. GAN objective makes the generated image close to in-distribution samples, and the KL divergence term makes it not belong to any classes, resulting in out-of-distribution. When we optimize the above objective function, one can observe that generated samples are out-of-distribution samples close to in-distribution. Finally, we train a confidence calibrated classifier using the confidence loss and the out-of-distribution GAN. We use alternating scheme to optimize joint confidence loss. Next, I'll explain how to execute the source code and how we implemented explained features. You can clone the source code from the following GitHub. You need PyTorch with GPU and the code is tested under Ubuntu 16 and Python 2.7. You can download the dataset from the following link. In the repo, there are source code and script files. There are 3 script files, one for training a model using the standard cross-entropy loss, another for training a model using our joint confidence loss, and test script that can evaluate trained model. Each script executes Python source codes and saves result in results directory. In run joint-confidence.py file, we first define the classifier and the GAN generating OOD samples and corresponding optimizers. We optimize the discriminator of GAN to predict 1 for the real data and 0 for the generated data. On the other hand, we optimize the generator of GAN to discriminator predict 1 for the generated data and output a classifier to close to the uniform distribution. Finally, the classifier is trained using standard cross-entropy for weird data and minimizing K divergence between its output and the uniform distribution for generated data. If you run the script, you can find a folder is generated under results directory. There is a log text file that the training procedure is logged, and the JPEG files that GAN generated for each epoch. And this is the end of this tutorial. Thank you.